Greetings, ladies and gentlemen. Welcome to Nostec Academy. In this video, we're going to balance chemical equations. Okay, we're going to concentrate much on the most common ones. We're going to answer from question 1 to 20 to question 13. Okay, so we're going to start with the basics and then we'll be progressing, okay, to more challenging questions. Without wasting much of the time, let's get started with the first question. So the first, we are given this equation. This is nitrogen, this is hydrogen. So this is nitrogen reacting with hydrogen to form ammonia. This is ammonia, and this reaction is a reversible reaction. Okay? This is the reaction used in the Haber process, the initial stage. So now, balancing chemical equations, you need to know that the number of atoms of a specific element must be equal, on the reactant side must be equal with, to the number of elements on the product side. What I mean is, so if we have two atoms of nitrogen this side also should have 2 atoms of nitrogen, or else you need to balance it. So on the reactant side, we have 2 atoms of nitrogen. Then on the product side, we only have 1 atom of nitrogen. So to balance the number of nitrogen atoms, we're going to put a 2. We always introduce the 2 in front as a coefficient, okay, in front of an element or a compound or a molecule. So if we put a 2 here, then we have 2 atoms of nitrogen on the reactant and 2 atoms of nitrogen on the product side. All right. The nitrogen is balanced. Let's go to hydrogen. Hydrogen, we have 2 atoms of hydrogen. Then this side, remember, the number you put in front of an element or a radical compound affects everything, every element. So we have we already have 3 atoms of hydrogen here, so we're going to multiply 3 times 2. So in short, we have 6 atoms of hydrogen. Then this side we have 2. So how can we make these 2 6? How can we change 2 to 6? By putting a 3 in front of hydrogen, not changing these 2 to 6. No. Okay? So you double check. Nitrogen is 2, nitrogen is also 2 this side. Hydrogen, 3 times 2 is 6, 3 times 2 is also 6. So this equation is balanced. Let's go to question number 2. This is aluminium, this is oxygen. Then what is formed there is the aluminium oxide. All right? So we do the same. We have 1 atom of aluminum on the reactant side. Then on the product side, we have 2. So to balance aluminum, we are going to write a 2 here on the reactant side. Okay? So aluminum is balanced. And then we go to the next element, which is oxygen. The number of oxygen on the reactant side is 2. Then the number of oxygen on the product side is 3. So, to balance this, we are going to say, if we put a 2 here, it will be 4. And there is no way 3 can be 4 without using a decimal number. And we don't use decimal numbers in chemistry when balancing chemical equations. Okay? So, the nearest number between 2 and 6, or the even number, between 2 and 3 is 6. Because 2 can't be changed to 5, can't be changed to 4, but both can be changed to 6. So here we can write 3, and this one becomes 6. Then here we can introduce 2 in front of aluminum here. So never mind if aluminum, the number of atoms of aluminum balanced earlier, don't mind. So this times 3, this is 6, but the number of aluminum has been affected because of these 2. So what we are going to do, since here is 4, We are going to change this 2 to 4. Then check. The number of atoms of aluminum is 4. The number of atoms of aluminum is also 4 because 2 times 2 is 4. Then the number of atoms of oxygen is 6. The number of atoms of oxygen also is 2 times 3, which is also 6. Then our equation is balanced. Okay. The third equation, we have aluminum reacting with hydrochloric acid, okay, to form aluminum chloride and hydrogen gas. So, this aluminum here, a number of atoms of aluminum we have 1, number of atoms of aluminum we also have 1 here, so it's balanced. Then hydrogen 1, hydrogen this side we have 2. So we're going to put a 2 here so that hydrogen also balances. Then chlorine is 2 because of these 2. Then the other side here, the number of chlorine atoms is 3. So what are we going to do? Remember what we've done previously here between 2 and 3. We can change. Can we change this to 6 or what? Anyone with an idea what we can do between chlorine atom this side and this side? Here we have 2 and this side we have 3. Remember the 2 is not here, the 2 is in front as a coefficient. What do we do?
So there we supposed to add the 6 in front of the 2, then there we add the 2.
So you're saying we add the 6 here, so the number of chlorine atoms becomes 6, then we add the 2 here, so that the number of chlorine atoms balance, right? That's correct, because we have a 6 between 2 and 3. We can use, we can multiply either. Now the 2 is not here. If the 2 was here, we would have used the 3 to change it to what? To 6. But now we had a 2 here as the coefficient in front. So the only way we can do this is by putting a 2 here so that the number of chlorine atoms balances to 6, and here putting a what? A 6 so that the number of chlorine atoms also what? Balances. Now remember, the number you're going to put in front will also affect the other what? Atoms, right? Okay. So when you look at hydrogen, okay, now before even looking at hydrogen, we can see aluminum has been what? Affected. So we have 1 here, this side we have what? 2. So we can put 2 here, and aluminum now, the number of atoms of aluminum balances. Okay. Then in hydrogen you have 2, this side we have what? 6. So what number can we put here so it becomes 6? 3, right? Very good. Let's double check. Is this equation balanced? You have 2 atoms of aluminum, 2 atoms of aluminum, 6 atoms of hydrogen, 6 atoms of what? Hydrogen, 6 atoms of chlorine, 6 atoms of what? So this one also is what? Nice. Go to 4. This is glucose, huh? Okay, glucose reacting with oxygen here to form carbon dioxide and what? And water. All right, so we have 6 atoms of carbon on the reactant side, right? Then on the product side, we have how many? On the reactant side, product side, how many atoms of carbon? 1, right? So we're going to put 6 atoms, 6, right? So that number of carbon atoms will do what? Balance. Okay? You go to the next is hydrogen, right? Hydrogen here is what? 12. Hydrogen is 12. Come in. Hydrogen is 12. Then here hydrogen is how? How many atoms of hydrogen? 2, right? Now which number can we put in front of H2 hydrogen to make it 12? 6, right? Yes. Very good. 6. Then next is what? Oxygen. Now, oxygen we have 6 plus 2 on the reactant side, so which is what? 8, right? We have 8 on the reactant side. Now, how many atoms of oxygen do we have on the product side?
3.
18.
We have 18, right? So you have 6 times 2, 12 plus 6, right? So on the product side we have 18, this side we have what? 8. So which number can we put here so that when you add it to 6, it becomes 18? So if you put 6 here, 6 times 2? 12 plus 6?
18.
So this one is also balanced. Okay? We go to the next. What's the name of this compound? Ethanol, right?
Yes.
No. All right. So, ethanol reacting with oxygen to form carbon dioxide and what? Carbon dioxide and water. So what we're going to do is, don't worry even if you don't know the name of the compound. When it comes to balancing, the name of the compound doesn't matter. What matters is the atoms, individual atoms that are what involved. Let's now balance it. Number of carbon atoms you have how many?
2.
Then this side we have 1. So we're going to put a what? A 2. Now remember, what you are doing here, whatever you are doing, use a pencil. Okay? Use a pencil because it's not a guarantee that this 2 you put here is permanent. Okay? This one is bound to change. So you can change it. Alright, we go to the next. How many atoms of hydrogen do we have on the reactant side? 5 plus 1, 6, right? You have 6. How about here? So we're going to put what? 3. So 3 times 2, 6, right? Nice. We go to the next, oxy. How many atoms of oxygen do we have on the reactant side? 3. How about here?
3 also.
Bear in mind the coefficient. So we have 2 times 2. 2 times 2? 4 plus 3.
7.
So we have 7 this side, eh? Then this side we have a 2 here. So what number can we put in front of the oxygen? Remember, this oxygen is independent, huh? So that when we add it to 1, this oxygen, it becomes 7 as well.
3.
If we put 3 here, 3 times 2
6.
plus 1?
7.
Oh. So this is 2 times 2 plus 3? 7. Let's double check. Number of carbon atoms 2 here. Hydrogen 6, oxygen 7, even this one balanced. Okay. Okay, so now calcium carbonate reacting with dilute hydrochloric acid to produce 3 products: calcium chloride, water, and carbon dioxide. Very good. So we have 1 atom of calcium on the left hand side. Even here we have how many atoms? 1 atom. So this carbon, this is carbon. Alright? How many atoms of carbon? Remember, this is not carbon, it's chlorine. This is not carbon, it's calcium, it's Ca. So you only have 1 carbon, atom of carbon. How about here? This is not carbon, this is not carbon.
1.
We have 1. How about oxygen? Oxygen we have 3, How about here? This side 3. Come in. 3. Okay, you have 3. This side is 3. Let's go to hydrogen. Hydrogen we have how many?
1.
On the product side? 2. So I'm going to put a 2 here, right? So that the number of hydrogen atoms also balance. Okay? Alright, balances the number of hydrogen atoms. So by putting a 2 in front, a hydrogen balances. Alright? The next is chlorine. How many atoms of chlorine do we have? 2 are because of this 2, right? Then how many atoms of chlorine do you have on this side? 2. Balance it. So this equation is balanced, right? So C1, calcium 1, that side. Carbon 1, oxygen 3, oxygen, because 1 plus 2 is 3. Hydrogen 2, chlorine 2, this one also balanced. Okay, number 7, ion reacting with what? Water. Okay, water to form, what is the name of this compound?
Iron tetra.
So it is triion tetra oxide, triion tetra oxide, and then hydrogen gas there. So never mind, let's balance it. You have 1 atom of iron on the pro-reactant side. Then on the product side, you have how many? 3. You have 3 atoms. Now, how can we balance this? By writing a 3, putting a 3 here. So if we put a 3, then the number of ion atoms will do what? Balance. We go to the next, hydrogen, how many?
2.
This side?
2.
Oxygen?
1.
Oxygen?
4.
What can you do? By putting a what?
4.
A 4,
Yes.
If we put a 4 here, then the oxygen balances, but the number of hydrogen atoms have been what?
50.
So this is 4 times 2 is what?
8.
Which number can you put here so that when you multiply it by 2 it becomes 8 as well? 4. So this is what? It has balanced. Next is what? Number 8, which is aluminum reacting with, this is also an acid, This is sulfuric acid. So this is displacement, single displacement. The aluminum will displace the less reactive element from this sulfuric acid, which is hydrogen. Because aluminum is above hydrogen in the reactivity series, so this one will be displaced and it will be as hydrogen gas there. Then this will attach itself to sulfate and to be aluminum sulfate. Okay, let's balance it. We have 1 atom of aluminum. Here we have how many? 2. So we're going to put what? 2. Hydrogen, you have how many? 2, right?
Yes.
Then this side?
2.
2, right?
Yes.
Sulfur?
1.
Sulfur?
3.
Sulfur 3, because of this 3, right?
Yes.
Okay. 3. So what do? We put a 3 here. If we put a 3 here, sulfur will balance. But hydrogen has been what? Hydrogen is what now? Here. So what we are going to do? We add a 3 here. So it becomes also 6. Then we go to O. How many atoms of oxygen here? 3 times 4 is what? Very good. How about here? 4 times 3? 12. Aluminum 2. Hydrogen 6. Hydrogen here. What's next? Sulfur. Sulfur here.
3.
Oxygen.
12.
Oh, because of this,
Yes.
Even here oxygen what? 12. So we've done questions 1 up to what? Questions 8. Okay, we are remaining with 5 more questions. So this is more like part 2 of the first of this video. So like I said that we started with the basics, then this is the last part. Right? So the last part will be more challenging. Okay? So the first one, which is question 9, sodium hydroxide reacting with ammonium sulfate to form sodium sulfate, water, and ammonia gas. That's right. All right. So how many atoms of ammonia sodium do we have on the reactant side? We have 1. How about on the product side? 2. So I'm going to put a what? A 2 here, so that the number of sodium atoms is equal to the number of sodium atoms on the product side. All right. Now remember, you can't solve equations involving calculations involving equations when it comes to stoichiometric equations or more concepts without knowing how to balance the chemical equations. It's very difficult. Finding percentage yield, percentage purity, and also limiting reagents require you to balance the equation, to come up with equations and balance them. Normally, these equations are given, but you need to balance them on your own. So, that's it. We proceed. The next is what? Oxygen, right? So, the number of oxygen atoms on the reactant side, we have 2 plus 4, right? 2 plus 4 is what?
6.
2 plus 4, 6. This side we have 4 plus is what? 5. Now I can change this one to 6 again by putting a 2 here or 2 here. Where there is water, if you put 2 here, it will be 4 plus 2 and becomes what? 6. Right? So the number of oxygen atoms balanced. So we go to the next, hydrogen. So we have 2 plus 8, right?
Yes.
So 2 plus 8 is what? 10. So 10 atoms of hydrogen. And then on the product side here, we have, this is what? 4. Then this is 4 plus 3? 4 plus 3 is 7. Now how can you make this one 10 to have 10 atoms? Let's think. On the right hand side we have 2 plus 8, which is 10. We have 10 here. Then this side we also have we have 4 plus 3, which is what? Which is 7. What are we going to do? Yes, Joseph? In front of ammonia. So if we put 2 here, the number of hydrogen atoms becomes 6, right? Then this is 4, right? Very good. So 4 plus 6 is what? 10. Brilliant. Next is what? Nitrogen, right? The number of nitrogen atoms is what? 2. Here, 2. Good. Sulfur here, 1. We're done with oxygen, right? Yes. Let's check. Sodium 1, or sodium 2, oxygen, you have 2 plus 4, 6, right? So 4 plus 2, 6. Hydrogen, you have 2 plus 8, 10, right? And here you have 4 plus 6, 10. Sulfur, 1. Sulfur, this one, this equation, exactly, balanced. Go to the next. Next one is what? What's the name of this compound? Butane. So butane reacting with oxygen to form carbon dioxide and water. Exactly. So the number of carbon atoms on the reactant side is 4. The number of carbon atoms on the product side is 1, right? So I'm going to write to put what number here? So I'm going to put 4. The next is hydrogen. How many hydrogen atoms do we have on the reactant side? We have 10, right? Okay, we have 10. On the product side we have So what I'm going to put here is make it 10.
5.
Okay, put 5, it becomes 10. 5 times 2, 10. 10. Nice. We go to oxygen, right? Uh-huh. Oxygen is what? Then here we have 4 times 2 plus 5.
13.
This is 4 times 2, 8. 8 plus 5, 13. Okay. You have 13. Then this side we have 2. What are we going to do to balance it? Which number can we put in front of O2 oxygen here to make it 13? Not a decimal number. We don't have that number. Eh?
Yes.
We don't have. If we put 6, it becomes 12. If we put 7, it becomes 14, which is greater than what? 13. So it means that the 13 should change, and here we should put another number. Right?
Yes.
So if we put 8, if this one becomes 16, can the number of oxygen also change here to 16? Yes, see? So this is 4 times 2, 8. Now if we change this one to 8, it will be 8 plus 8, which is what?
16.
Then this one we put here, put 8. Are we together?
Yes.
Very good. Put 8. So this is where you have to be very careful. That's why you need to do a lot of what? A lot of practice. Eh? You practice a lot. Because some of the equations are challenging. Okay. Okay. So like this equation, this one was 2. Then here 30. 13 when you add 4 or add 8 plus 5. We had the 5 earlier on. We had the 5. So now the 2 can't be changed to 13 if you by putting any number other than a whole number. I mean, other than a whole number, yes, other than a decimal. But we're not supposed to use decimals here. So what we need to do is to use whole numbers. All right, not fractions. All right. So the next one is what? Let's revisit. The number of carbon atoms is what?
4.
Hydrogen.
10.
Hydrogen here. 8 times 2. 8 times 2 16. Now is this 16?
No.
How can we change this one? This is another situation. We have 10 here, and here we have 16. Mind you, we have 10. The number we're going to put here can either be not 1, but 2. 2 will be 20, right? 3 will be 30, 4 will be 40. So if we put it 2, will be 20. Now, how can we change the number of hydrogen atoms here? We already have a 2. How can we change this 2 to 20? By putting a 10 here in front,
Yes.
Okay. So if we put a 2 here, okay, and change this one to what? To 10. All right. So it is a step by step. Yes, the number of oxygen atoms balanced earlier on, but the number of hydrogen atoms have been what? Has been affected. Has been affected. So if we use 10, this will be 20, right? 20. Then here also will be 20. But the number of oxygen atoms has oxygen and carbon have been what? Affected. So let's start with carbon first. Carbon here is what? Carbon here 4. So I'm going to change this one to what? 8, because we only have what? 1 here. So 8. Next is oxy. This side you have 16. This side you have 10 plus
16.
10 plus what? What is 10 plus 16?
6.
So this side we have 26. Now, what number can we put in front of oxygen? O2, we already have a 2. Or which number can you multiply by 2 to give us 26? 13, right? So 13. So we have 8 atoms of carbon, right?
Yes.
Then 8 atoms of carbon, we have 2 times 10, 20 atoms of hydrogen. This side we have 20 atoms of hydrogen, right? Okay. Then 13 times 2, 26 atoms of oxygen. Then this side we have 8 times 2, 16 plus 10, 26 atoms of oxygen. Therefore, this equation balanced. It's never been easy, but with practice, it becomes enjoyable. All right, number 11. This is chlorine, this is ammonia, this is nitrogen gas, this is the ammonium chloride. The number, remember, our chlorine is found in group 7 of the periodic table. So all elements in group 7 of the periodic table exist as diatomic molecules. Come in. Diatomic molecules. So this will be, we have 2 atoms. Here we have 1 atom of chlorine, right? Chlorine. So we're going to put a 2 here. So you start with the basics. You don't just come up with these big numbers. Okay? You start with the basic, you change numbers, you erase. That's why you're supposed to use a pencil. Okay? You're supposed to use a pencil. Gradually, boom, these big numbers. So we put a 2 there. Okay? The nitrogen here, not ammonia, but just nitro, but because we're considering elements and not compounds. We only have 1. How about here? 1. It's 1 here. Then here we have 2 plus 2, 4. So we're going to write a 4. So that the number of nitrogen atoms balances. We go to what? Hydrogen. 4. Here we have how many? 12. 4 times 3, 12. How about here? 8. So we're going to change the 2 to what? To 3, so that it becomes 12, right? Now bear in mind that the 3 you're introducing here affects everything. Okay? Then you double check the number of atoms that have been affected. I mean, the atoms that have been affected. You have chlorine has been affected, and nitrogen also has been affected. So you have 2 atoms of chlorine here. Then this side you have how many? 3. That situation we have 2 here. Then this side you have how can you balance the 2? By writing a 3 and becomes 6, and then here introducing a 6, right? Now if we put a 3 here, the number of chlorine atoms will what? Will balance, right? Then here we are going to change a 3 to 6 because we only have 1 atom of chlorine this side. So we are going to write a 6 here, and the number of chlorine atoms in balances. Next is the nitrogen. This side we have how many? This side we have 6 plus 2?
8.
We have 8, yeah? So now without the 4, there is 1, eh? So which number can you put so that it becomes 8? 8 is so far. So 4 out, 8 in. Okay? Then what do? We go to hydrogen. Because of the 8 that has been introduced here, the number of hydrogen atoms also has been affected. So 8 times 3, 24, right? 8 times 3 is 24. Then what is 6 times 4? 24, right? Okay, let's check. How many atoms of chlorine do we have on the reactant side? 6. Very good. Here, 6 as well. Nitrogen. Nitrogen here, 6 plus 2, 8. Hydrogen. Hydrogen. So this equation has also balanced. Okay? Okay, this is how easy these things are. Then we go to the second last, okay, of, yeah. So, what's the name of this compound? Hexane, Yes, hexane. So this one comes from the family of alkanes. This is under organic chemistry, and it's number 6. This member is number 6 in their family. Okay, the first one should be methane. Then you have ethane, propane, butane, and so on. And number 6 is what? Hexane. All right. Let's balance it. You have 6 atoms of carbon. This side you have we start with the basics. So by writing what? A 6 there, so that the number of hydrogen, carbon atoms balances as well. Hydrogen is how many? 14 on the reactant side. Then on the product side we have so we can put what number here? 7. So that 7 times 2 is what? 14. Okay, this one looks easier until oxygen. Okay, oxygen you have this side 6 times 2 plus 7, 19. Do you have what? Do you have a number which, when multiplied by 2, would give us 19? No. There is no. There is a? No. So what are we going to do? What are we going to do? Remember what we've done in the question 10 there. This one will change by 2 because we only have one molecule of high oxygen on the reactant and 2 atoms, right? So the number we're going to put here will be multiplied by how many? Very good. And we can't put a number which is less than 8, because if we put 8 here, it will be 16. If we put 9, it will be 18, which is less than 19. Okay? Now let's try 20. Let's try what? 20. Let's put 10 here, and let's change 19 to 12. If at all we can, right? So this is 6 times 2 is what? 12. Oh wow, we can. We can? The number we can add to 12 to make it 20 is 8, right? So the 7 will change because there's 1 here. The 7 will change to? Very good. So 6 times 2, 12. 12 plus 8, you see? 20. 12? And this side we have how many? 20. All right. The 8 we've introduced there has also affected what is other atoms, which is this is what? Hydrogen. So number of carbon 6, hydrogen 4, 14 here, then here hydrogen you have what? 16. Now what do we do? Here you have 14. Then this side you have how many? 8 times 2, 16, huh? You have 16. What do we do? By the way, there is no way 14 will change into 16. A number we're going to put in front here will be greater than 2, 1, eh? If we put 2, it will be 20. 28, right? If we put 2, it will be 28. Now, can this 2 change to 28? Here, 2.
Yes.
By writing 14, eh? So let's put 2 here, and if hydrogen becomes 20 what? 28, right? Then here we can change 80 to 14. Okay, to 14. You thought it was over? Okay. Alright, next is carbon 6 here, carbon here, 12 here, 6 here. So we're going to put what? We're going to put we put 12.
Yes.
Okay. If we put 12 there, the number of carbon atoms balances, yes. But the number of oxygen has been affected, greatly affected, in fact. Okay? This side you have only 20. Then this side, now this is now easy because we only have to change here, and we have 2. We have what? Don't be on pressure. The 10 will change. Now we have 12 times 2, so we have 24 plus 4, 14, which is what? 30. You are intelligent. Now, which number can we add in front of 2? Can we multiply by 2 to give us 38? What is, yes, half of 38? 19. 19 times 2, 30? 38,
Yes, sir.
Okay, let's now check. Number of carbon atoms. Number of carbon atoms. Hydrogen atoms. 28, Hydrogen atoms. Oxygen. 38, Then this is 12 times 2, 24. 24 plus 14, 38. Finally, this one has it. It is 2, 19, 12, 14. Now let's go to the last one. This would have been the last one, because this one is not as challenging as this one. Okay, so we have this one. The number of aluminum atoms on the reactant side is 1, and the number of aluminum atoms on the product side is so we put a 2. Okay, it starts as simple, as basic as this. Okay, until you reach to 19 and then 14. All right, next is copper. This is copper. Yes. Copper is 1. Copper here. 1. Okay. Sulfur. 3. So we're going to put a what? 3. Not here, but in front of what? In front, as a coefficient in front of the compound, the whole compound. Okay. So by putting a 3, copper has been affected. So even here, since it's independent, we can add a 3 there, so that copper also balance. Oxygen. Oxygen, this side you have? This side? This was balanced, right? Okay. So number of aluminum atoms. The number of aluminum atoms. The number of copper, atoms of copper. This side. Sulfur. Sulfur. Here. Because of this 3 which is outside there. Oxygen. 3 times 4. Oxygen 3 times 4. 12. Alright. So this also is what? Okay. Balance. So thank you so much for being with us. Remember to subscribe to the channel. It's the only way you can help the channel grow and help it to recommend it to other viewers as well. Thank you so much.